right, your goal while watching this video is to be able to tell me what an algebraic expression is and to identify the different parts of an algebraic expression. As we go, if you need more time to write down the notes that I give you, please pause the video and jot them down. All right, so first, an algebraic expression is a big fancy way to say something that's not really too complicated at all. So I'm going to give you an example of an algebraic expression. Let's do 2x to the second plus 3 minus 2. So an algebraic expression is like a math phrase. It combines letters or variables and numbers and operations. One thing that makes an algebraic expression different from an equation is it does not have an equal sign. So the first thing you should make sure you write down is that definition for algebraic expression. Combines numbers, variables, and operations, no equal sign, or it would be called an equation. Okay, so terms is like saying parts. Terms are parts of an algebraic expression. The terms are the parts that are connected by addition or subtraction. In the example that I wrote up here, all right, the terms are the parts that are connected by addition or subtraction. So here I have 2x to the second power, and it's connected by addition to 3, which is connected by subtraction to 2. All right, so there are 3 parts connected by addition or subtraction. My terms are 2x to the second, 3, and 2. All right, constants. Constants are the opposite of variables. So we've been talking about variables, which are things that have the power to change or things that are able to be changed. Constants are things that you just can't change. So if I go up to this example expression that I wrote, I look at my first term. That term has a variable in it. It has something that's in it that's able to be changed. This second term right here, 3, does not have a variable. Okay, so 3 we would consider a constant. It's constantly the same. It's not able to be changed. So we have a constant of 3, and we also have a constant of 2. That 3 and that number 2, neither of them have a variable part. So neither of them can be changed. They are both constant. So a constant is a number without a variable. Pause if you need more time to write that down. Coefficients then. I like to look at the word part, kind of like when we were word mapping variables. This one has a prefix of co, and co means with. So we're looking for something that's with something else. A coefficient is a number that is with a variable, so a number that is in front of a variable. In this example expression up here, we have one coefficient. We have one number that's with a variable. This 2 would be considered a coefficient in the expression. Pause if you need more time to write these definitions down. All right, so now we're going to actually apply what we know about that and identify the terms coefficients and constants in each of these, starting with part A. All right, so first, terms. Remember, terms are the parts that are connected by addition or subtraction. So in this one, I have 2 terms. All right, so my terms are 5x and 13. Pretty easy, huh? All right, then you go to coefficient. Remember, co means with. So coefficients are numbers with a variable part attached. So if I look at this one, I see that there's a variable part and there's a number in front. My coefficient, or my number with the variable, is 5. The number that comes in front of the variable. If I look at my second term, that one does not have a variable part, so there is no coefficient. Constants are things that never change. All right, so something that is constant, something that never changes. And since this term of 13 does not have a variable with it, it won't change. So 13 is our constant. This other term, 5x, has a variable, and a variable has the power to change. So that one would not be a constant. If we move over to example B, how many terms do we have? How many things do we have connected by addition or subtraction? 1, 2, 3. All right, so my terms are 2b to the second, y, and 3. Coefficients. Remember, co means with. So coefficients are numbers with variables. Here we have a 2 with the variable, In my second term, and this is a little bit tricky, not tricky, but it's something you gotta remember, all right? Here, I have a variable, but there's no number in front. If there's no number in front of a variable, it's like saying there's a 1 in front of it. How many y's are there? There's 1 y. So the coefficient of y is 1. And then this one, this term of 3 has no variable in front. So that one does not have a coefficient. All right? Constant. Constant is a term that has no variable. 3 has no variable. All right, write each expression using exponents. So here, for part A, we have a variable, D, being multiplied. Let's back it up and pretend it's not a variable. Let's pretend it's a number. Let's pretend it's 2 times 2 times 2 times 2. So in this case, I could write it as a base with an exponent by saying, okay, what is my factor being multiplied? 2 is being multiplied. How many times? 4 times. So we could say that's 2 to the 4th power. Here we could say what factor is being multiplied? D is being multiplied. How many times? Is D a factor, or how many times is it being multiplied? 4. So this would be your answer to part A. For part B, I have 2 different kinds of factors. I have a number, and I have 3 variables. I'm going to focus on this variable part first and say, okay, I have h being multiplied. So that's my base. How many times am I multiplying h? 3 times. H is a factor 3 times. Then we could just say, okay, I'm going to take 1.5 times that. This is the correct answer, but you could also write it as 1.5 h to the 3rd, where you don't write anything in between here. All right, if you have a number right next to a variable, it's kind of like a number right next to parentheses, it means multiply. So this would be the simplest, most condensed down way to write that. Okay. Oh, these are my favorite, pretty easy. Okay, so part A, evaluate k plus 10 when k equals 25. So we've already talked about the fact that equals means the same as. So here they're saying k is the same as 25. All right, well, if k is the same as 25, right here, why don't I put 25 instead of k? All right, so I'm going to put my value of the variable, so my number for the variable, in parentheses. You'll find out later why we do that. So it says k, I'm going to put this instead. K and this are the same. So I'm going to say k is 25 plus 10. 25 plus 10 is 35. Done. All right, part B. Evaluate 4 times n when n is the same as 12. So again, I'm going to just write this bigger, and you don't have to do that. I say n is 12, I'm going to put it in parentheses. I'll find out why later. And I'm going to plug it in. So instead of saying 4 times n, I'm going to say 4 times 12, because n is the same as 12. And 4 times 12 is, whoops, what's in parentheses? 4 times 12 is 40. Okay, example 4, evaluating an expression with 2 variables. So here's an expression, a divided by b. It has variables, it has operations, but it does not have equals. We want to evaluate it when a is the same as 16, just rewriting it so it's bigger, all right, and b is the same as 2/3. Okay, so over here where it says a, we know what a is, we know that it's 16. We know what b is. B is 2/3. Okay, so now I just evaluate. Turn 16 into a fraction. Change divide to multiply. Take the reciprocal of 2/3. Okay, so I can multiply that out, get my fraction, simplify it. You do that on your paper. If you need more time, pause it, finish that up before you go out. All right, last example. Evaluate 3x minus 14 when x is 5. All right, I'm going to write it bigger. 3x minus 14 when x equals 5. Here's my expression. So this is the expression. It has no equal sign, combines letters, variables, and operations. Tells me x is 5. This is where I want to use parentheses before I substitute it in. X is the same as 5. So over here I'm going to say 3x is the same as 5 minus 14. Now this is why I keep saying put your variable value in parentheses. Because if we had not put parentheses, we would have done this. we would have said 3, x is 5 minus 14. And these are two very different things. 35 minus 14 is like 21. Okay? But here, this really means 3 times 5 minus 14. 3 times 5 is 15. Minus 14 is 1. Okay? Get that written down. I'm going to erase it so I have more room for part B. Okay, part B. Evaluate z to the second plus 8.5 when z equals or is the same as 2. All right, so in this case, again, before you put your number in for z, put it in parentheses. All right, so here we're going to say, here's our expression. We're going to substitute 2 for z, so we have 2 to the second plus 8.5. Order of operations tells me do exponents first.
Yeah.
And then add. All right, finish evaluating that problem on your paper. Make sure your notes are complete and raise your hand so we can check them and we can move on.